current and resistance. Here are priming questions. What are the important equations? And what are they similar to? So this is back to some old material. What is resistance? And why is resistance important for devices? This will be one of your thinking questions. I'm not going to address this directly in the presentation. And then for a given material, what are the ways to manipulate the resistance? And hopefully you're starting to see a little bit of a commonality between some of these questions. You need to be thinking about resistance, what it is, why it's important. All right, so let's get started with current. We can think of current as the flow of electrons. Another way of thinking about it is charge per unit time. Right? If they're flowing, they're going to be a certain number of electrons that flow, so they're going to have a certain charge for a certain amount of time. The units that we use with this are the ampere, what we also call amps. The variable that we use in our equation is the I, and the symbol that we use for the amp is the A. Here it's capital A, but sometimes we can also use the lowercase. Either way, it doesn't matter. So, charge per unit time, so we can think of I is equal to Q over T. Okay, so if we look at this, what is 1 amp equal to? 1 amp, so 1 amp is going to be equal to 1 coulomb per second. 1 coulomb per 1 second. Now, conventional current flows positive to negative, and this was established when they were first figuring things out about electricity. And if you think about what we've talked about so far with what can move, what is peculiar about this? So that's one of your thinking questions. We'll come back to that in class. Electric potential energy is the product of the charge and potential difference. So E is equal to QV. Now if you think back to the last unit, you've already seen this equation. We use this as the voltage equation. Voltage is equal to the energy per charge. And so this is the same equation, just rewritten a little bit differently and from a different perspective. So E is equal to QV, or V is equal to E over Q. They're the same equation. All right, resistance and Ohm's law. So resistance is the opposition to the flow of electric current, so the opposition. It's going to reduce the flow. It's going to prevent it from moving as quickly as it could. We measure this in ohms, and we use the omega symbol for this. You can think of resistance as the ratio of the potential difference, what we also call the voltage, to the current, the I. So R is equal to V over I. Oftentimes we will see this rearranged as V equals IR. And if you want to rearrange it again, I is equal to V over R. These three equations, let me box these in green, these three equations are the exact same. I would only memorize or remember one of them and then be able to manipulate it wherever you need to. The one that I typically remember is V equals IR. So, what are two ways of controlling the current? If we're looking at our equation here, so we're looking at the I now, we can manipulate the V and manipulate the R. What you want to be thinking about are the relationships between the variables. Is it linear? Is it inverse? Is it direct? Things like that. We'll talk more about those relationships. See if you can come up with those relationships and see if the person next to you in class found the same relationships between those variables. Now, a little bit more on resistance. Resistance depends on the type of material as well as diameter and the length. So material, diameter, length. So for example, most of our wiring uses copper. Copper has less resistance than aluminum, all else being equal, meaning the same diameter and the same length. Now, a wider copper will have less resistance, and a longer copper wire will have more resistance. Okay. The equation that you want to be familiar with is this. Resistance is equal to rho times L over A, where rho is the resistivity constant of the material in ohm meters, L is the length in meters, A is the area in meters squared. Be careful of your units. This table will be given to you in the future, so you don't need to memorize these particular values. Depending on what material you're working with, you'll have a different resistivity, and some of these, you'll notice, have a range of resistivities as well. We will typically be just working with the metals. Okay, so that is resistivity. We'll go through some questions in class and talk a bit more in depth about this. So, a couple of practice problems, and then I'm going to leave you off with a practice problem to work on by yourselves. The compressor on a refrigerator draws 12.2 amps when it starts up. The startup time is about 0.349 seconds. How much charge passes across sectional area of the unit in this time? So, we are given the current, the time, and we're looking for the charge. So the equation that we should be thinking of is I is equal to Q over T. And we are told that we have 12.2 amps, so I is equal to 12.2. We are told that we have a time of 0.349 seconds. And so we just need to plug this in because we're looking for the Q. So we have 12.2 is equal to Q over 0.349. So our Q is equal to 4.26 coulombs. There you go. The next question. A total charge of 9.24 millicoulombs passes through a cross-sectional area of wire in 4.28 seconds. What is the current in the wire? So with this one, you have to be careful of your units. We are in millicoulombs, so this is going to be our Q, is going to be 9.24. Milli is times 10 to the negative third coulombs. We are told we have 4.28 seconds. And we are looking for the current. We're looking for the I. So we know I is equal to Q over T. So we have I is equal to 9.24 e negative 3 over 4.28. So we get a current of 0.00216 amps. The next question. A potential difference of 103 volts produces a current of 7.00 amps in a certain resistor. What is its resistance? We have our voltage of 103 volts. We are given our current of 7.00 amps. We are looking for our resistance. So we need to use Ohm's law, V equals IR. And so we have 103 is equal to 7R. So our resistance is equal to 14.7 ohms. Give these problems a try. If you're in regular, you have these two. If you are in advanced, you will be doing all of these. We're going to go through these in class. I want you to be able to compare with the person next to you.